For problem 1210, the example comes to us right from Edina, Minnesota. So it's related to the change it made at its high school start from 7:25 to 8:30. The idea was that they thought if they gave teenagers more sleep, it would improve their learning, and they took SAT scores for a random sample of students taken before the change, and then a random sample of SAT scores after the change were recorded. And the question we're trying to answer is, can we infer from the data that SAT scores increased after the change in the school start time? So again, we're going to start with the X bar for 1, the before. It's the average. We're going over here to A2. If I hold my shift key down, hit the N key and then the down arrow, it brings us all the way down to A356, which is the end. And so we get an average of 496.87. Over here, we're going to do the same thing with the after scores on the SAT. In this case, it'll be B2, same technique, down to 289. Close it for an average of 511.292. Now we know, because A2 to A356 means N1 is 355, and here B2 to B289 is 288. Now, if you weren't sure how many were there, you could use, for instance, the count function and highlight the range the same way I did to create the sample mean there, the calculation. Now we want to go on and do the variance. In this case, it's VAR, and we're going to do it for a sample. So again, same technique. Hold the shift key down, go N down, and then back up here. Close the parentheses and click enter to give us 5,443 and 45. And we're going to do the same thing over here with sample 2, or variance 2, excuse me. Yeah, well, for the sample 2 we're going to calculate the variance, I should say. Hold down shift, N down, close the parentheses, hit enter, and now we can calculate the F statistic, the F test. It's take the first variance divided by the second, which gives us 1.14. And now what we want to do is calculate the rejection reason using the F inverse function equals F. And so we give it the probability, oops, that's not the one I wanted, I got the right, equals F. The probability is the 0.025. The degrees of freedom for the first sample, the before, is 355 minus 1, so 354. The degrees of freedom for the second is 288 minus 288 minus 1, which gives us 287. Close that for 0.8031. We can do the same thing for the after sample. The probability is 1 minus 0.025. Degrees of freedom 354 and 287, which gives us excuse me, 1.2484. So we can see right here that the rejection region would be an F test less than 0.8031 or an F greater than 1.2484, and since the F we calculated is 1.14, it's not in the rejection region, so we'll use the equal variances test statistic. And in this case, our hypothesis is that there's no difference between the before and after SAT scores. The idea or the thought for changing the school time to later was the idea that it would improve learning and therefore be reflected in higher SAT scores. So if you took the before mean minus the after mean, if the after mean is greater, then you would expect that number to be negative. So we're going to find out based on the sample we have, is that true or not? So we're going to calculate for t. So it's the t inverse. And again, the probability in this case is 0.05 because we only really care about it if it improved it. We're really thinking it didn't have a negative. And then for degrees of freedom, it's 641 because we take the 355 for the before sample, the 288 for the after sample, and minus the 2 to give us 641, which gives us minus 1.6472. So now we're going to compare that rejection region is if it's far enough on the negative to be less than this. When we calculate this t, we'll consider that to have been that it did make a difference. But in order to do that, we need to calculate the S sub p squared, which is also that pooled variance estimator. So let's do the calculation again, breaking it down first by numerator, which is equal to n1 minus 1 times variance 1 plus n2 minus 1 times the variance for 2. And then the denominator is simply n1 plus n2 minus 2. And then to get the S sub p squared, it's equal to the numerator divided by the denominator, which equals 5,141.547. So now that we have that, we're going to calculate the numerator here, which is simply the x bar 1 minus x bar 2, and again the population means we're going to assume there is no difference there, so it's 0, so that's a minus minus 14.4212. And then for the denominator, it's equal to the square root of the SP times 1 divided by n. Oops. Oh, it didn't like that. Sorry. Equals the square root of SP times 1 divided by n1 plus 1 divided by n2, 2 parentheses to close it, hit enter. Oh, here we go. That should have been not in the t, that should have been in the denominator. and then we take the numerator divided by the denominator, and that gives us a t-score of minus 2.53. Now if we compare this t versus the t calculated based on the alpha and the degrees of freedom, we see that the minus 2.53607 is less than the 1.6472, which means it would fall in the rejection region, and so there is enough evidence to conclude that the SAT scores improved after the change in school start time. Alright, that's it for 1210.